So here is your Workshop 5 math discussion. For this one, you're going to end up picking one of the 4 Excel files. Now, to know which one you pick, you want to make sure you pick the one that's based on the first letter of your last name. So for me, Italino, I would be picking the tuition one. Now I'm going to do a different example than that one so that everyone has a chance to work on their own. But just in essence, if I was a student, this is the one that I would be picking here. Now, by the end of the third day, what you want to do is make sure to post your Excel document, and in that Excel file, there's going to be questions. Make sure you post those questions with your answers right in the discussion forum. So we want the answer to the questions in the Excel document, and in that Excel document, you will be creating a scatter diagram, and I'll be demonstrating that for you right now. Now, next, the second and third post, after you finish your first, you want to take one of your classmates that completed a different problem. You want to review their problem, explain to them why you think the answers are correct or incorrect. And then you want to ask them questions or add observations to give depth to your discussion by introducing maybe new ideas. Again, throughout this whole course, we want to make sure that you show evidence of quantitative reasoning and critical thinking. That's the key here. For that third post, what you want to do is you're going to do, let's see here, it says complete one of the following. You want to do the same for another classmate, or you can respond to that classmate who responded to your initial posting, respond to their questions, observations, and thoughts. You need to make sure, again, you show that quantitative reasoning and critical thinking. Just short responses, I'm not allowed to give credit for. So make sure you demonstrate quantitative reasoning or critical thinking. And that's been an emphasis by the assistant dean, and it's coming down to all the math professors. So let's go through an example. So example here, so this time we have a delivery company buys a new truck for $92,000. The maker of the truck informs the company's CEO that on average it depreciates in value according to the schedule below. So here we go. If the depreciation continues at the same rate, how long will it take until the truck has no value? So we want to know when this will end up being 0. So we're going to try to get the slope here. So we're going to do, remember, rise over run. Rise over run. And just make sure to do it in the same order. Same order is important. And so we have rise, and this one's actually dropping, divide by. Now I did this first, so that means I have to do this one first. And there we go. I got negative 3,300. Now let's think about that for a second. Let's make sure it makes sense. So we have 92,000 went down to 75,500. So we're falling. So we're saying that we have a slope of negative 3,300. It does make sense. Now, if we did 92,000 minus 3,300, now that was for 5 years times 5, holds true. Good. So it's going down by 3,300 each year. So we want to know when that will be 0. We want to know when it'll be 0. So for that first one, y equals mx plus b. And so for this one we have, let's go ahead and we have a starting value of 92,000, so that's the b. We have a slope of negative 3,300, so that's the m. And so here we're going to end up with y equals negative 3,300 x plus the starting value. And now make sure here we're going to say let x equal the number of years after purchase. You want to be specific on that. And we can go ahead and figure out when this is 0. So we want to know when the value is 0. So what we're trying to find is when y is 0. That's what we want to know. And so to do that, we want to do the simple equation here. It's going to be 0 equals negative 3,300 x plus the 92,000. So that's what we want to do here. That's going to be our goal, is to figure out that equation. And let's just put it over here. All right. So that's what we want. We want when y equals 0, and so we have to solve that equation. And let's solve it. Now we need to move this 92,000 to the other side, so we're going to do that by subtracting. So on the other side, we're actually going to have negative 92,000. And then we have multiplication, so we're going to want to divide. So we're going to divide that by 3,300, but it's also a negative. Negative divided by negative is going to be a positive. So it's going to be approximately 27.87 years. So approximately 88 years. So what the number 1 is going to be, the value of the truck will be 0 at about 28 point, let's make sure we go back there, 88 years after purchase. And let's bring it over a little bit to make sure it displays nicely. Let's display a little better. So this is what I mean by sometimes Excel is a little finicky. I think, is that the right word? So this is why I say, hey, take your work, take your steps, make sure you show your work and explain your steps too. So make sure you do all that and put that in the discussion forum. So again, you want to make sure you attach your Excel document and make sure you have your explanations and work in the discussion forum to make sure it actually looks nice and is displayed nice. This isn't displayed very nicely here, so I'm going to try to fix it up a little bit. There we go. That looks much better. Alright, so I have it just displayed there nicely now for you. And let's take a look at the next question. Based on the pattern you see, so based on that pattern, how do you know that the graph will be a straight line? Well, based on this pattern, let's take a look. If we have a consistent slope, it's going to be rising and running at the same rate. And so what I'm going to do is I'm going to take this formula here and I'm going to click and drag it down and let it copy. There we go. And so by doing that, the slope between all of these points is the same. And since the slope is the same between all the points, again, it's rising and running at the same rate between points, meaning that we're going to have a linear relationship. So if the slope is consistent, it's going to be linear. So based on the pattern you see in the table, how do you think the graph will be a straight line? How do you know? Because we have a consistent slope, a consistent rate of change. So for this one, so again, to know that the graph will be a straight line, we look for a consistent slope. Since the slope is the same between each point, the graph of this data will be a line. So that's how we know. This next one here says pick an appropriate scale for each axis and graph the value of the truck until it reaches 0. Use the number of years as the first coordinate. So it's telling you use the years as the x. Alright, so we want this to go down to 0. So we don't have to go down to 0. So let's take a look. And so we know that at this particular example, it's at 28.88 years. So if I take a couple more data points, 20, 25, 30, at 30 it'll be less than 0. Obviously we can't have a negative value, but just to simply help us to get the graph. So let's fill in this chart here. Alright, and so the slope was negative 3,300, but if we notice here we're going by 5s in this chart. I was just continuing the chart as it was. So for every 5, let's figure that out. 92,000 minus 75,500. So for every 5 years, it's 16,500. So 42,500 minus 16,500. So this next one is going to be 26,000. And then we're going to subtract that same value again. So 9,500. And then over here, well, we can't subtract that again because that would be negative 7,000. Obviously, we can't have a negative value. So let's actually get the 0 value in here. Let's try to figure out how to make that work. So we want that 0 there, the value of 0. So how do we work a little backwards to get that there? Well, let's think about it. We have it right here. So over here we had 0 equals negative 3,300 x plus 92,000 right here. So we can put over here how to get that value. Well, equals, we did it right here. Negative 92,000 divided by negative 3,300. So that's what we're going to do right there. Negative 92,000 divided by negative 3. So there it is. Oh, I did have a little typo there. That was 27. Sorry about that. I'm not perfect. Mistakes happen. All right, so 27.88. But this is a more exact value because I put it in as a formula. So this one here is below it, so we'll take that one out. So now we have the more exact of when it is 0. So let's take a look here. So we want to pick an appropriate scale for the x-axis and graph the value of the truck until it reaches 0. So we have a scale here. Now we were going up by 5s, but the value is in between, but that's when it does equal 0. Okay. Find the slope of the graph. Oh, explain what it means. Well, we did find the slope, so let's just explain what it means. All right. And so the slope is negative 3,300. And the meaning of that is the value of the truck will decrease on average about $300 per year after the purchase. And of course, you always want to word it in a fashion like this because, you know, life is messy. Well, if that truck gets into an accident, the value is going to go down a little faster. So that's why I worded it like this. The value of the truck will decrease on average about $3,300 per year after the purchase. So let's go back. Number 3, as you see, I wrote scatter plot. But let me make sure that I show you how to do that. Scatter plot. We're going to click on the values we have here. We're going to go up to Insert. And up in Insert, we're going to go to, so let's make sure we get the correct one here. So we have a bunch of different options here. So this is Insert a line or area chart, but this one here, let's see, this one says Insert Scatter. So we'll click on that one. Now we want to emphasize the line, so we can insert a line here. So we'll click on that one. Now, if we click on here, we can right click and we can add a trend line, which we have, but we can also pick the equation. So we pick linear, and let's display the equation. Now R value is something that we'll learn about. You may learn about in a stats class, but I'll put it here just to emphasize something. This R squared value is correlation coefficient. Now some of you might take a stats course. The closer that value is to 1, what that means is the closer it is to 1, and if it is 1, that means it's an exact model. And so since this here is 1, this is telling me that this model here is exact for that data. So which we see it. All right. So the value in money is what this is. So we can actually type in here, let's see, the value of the truck. Okay. So we can make the scatter plot look nice. We can label the axes and stuff. So go ahead and just do it accordingly. So there is the scatter plot. So let's move this aside from our text box. Now I have this screen zoomed in quite a bit so we can see everything. So let's move that down here. And let's continue answering the questions. This one says, find the intercepts of the graph and describe what each means. Well, we've actually done that. So we already have the values. We just need to explain them. The first value is the 0, 92,000. So let's go ahead and type this up. So the y-intercept, number 5, the y-intercept is our starting value of 92,000. So at 92,000. The point is, the x value is 0, y value is 92,000. That's our starting value, what we started with at the actual purchase date. So starting value, let's put that in there, at the purchase date. And is 92,000. That sounds a little more grammatically correct. I'll never claim to be an expert at grammar, but I try. So the x-intercept is where, and now I'm just going to put a brief description here, is where the y value is 0. And the y value is the actual worth of the truck, is the actual value of the truck. So it's where it's 0, meaning where the truck's value is 0, which occurs at approximately let's see here, let's get it right this time, 27.88 years. And we don't want to forget the actual x-intercept point is about 27.88, 0. The reason why I say about is because we did round that number. And next one is, let's make sure we finish this up. If we use the letter x to represent the variable number of years, write an expression. I actually did that for you guys right here. That's actually the first one. I did it in the first step, but that's all right. So here we go. So I like to do it as an equation, so to me it's a little more visual, that first step. So if you did it already, you already got number 6 done. Some of you guys will probably do it that way. So this last one here says, use your expression from question 6 to find where the truck has no value. Now you can tell I'm a math teacher, so I should have did that part over here. Alright, so here we go. Let's go back through and make sure we finish up that other one above, so you know what's more expected of you for that first one. Because I'll even say it doesn't really necessarily say to use a graph for this one. So let's take a look here. It says if the depreciation continues at the same rate, how long will it take until the truck has no value? Okay, so we just use that. If we use that same rate basically here instead of what we did previously. So we used that actually for the last step. So let's show what I did here and explain the steps I use in Excel. Alright, so in Excel here, when I created this equation, we started with 92,000. It decreases by 3,300 per year. So we want to know when it gets down to a value of 0. So we need to know how many times does 3,300 go into 92,000. And we did that in Excel. We just simply did the 92,000 divided by the 3,300. And that equals the 27.88. Well, I should say about 27.88 years. So we basically want to know how many times that 3,300 goes into the 92,000, because that's how many times it'll take to get to 0 when we subtract. And it was approximately 27.88. So make sure when you go through and you calculate this and you determine it by the rate of change, just explain your steps, explain what you did and how you got to the final value. Now, me, of course, I typically jump the gun on things. But for this last one, it says use that expression. And so that's when we go back and we use the expression to find that 27.88. And now let's actually take this equation that we had here and let's go to desmos.com here and let's graph it on here. Now we're going to have to scroll out quite a bit on this one because we're dealing with 92,000. All right. And now when that was talking about before, let's think about that for that question that we had before. When this says here, pick an appropriate scale. Pick an appropriate scale is pretty important. So if we look at this here, yeah, I have it going up by 10,000s here. If you look at it, our scale is by 10,000s. And even going over here to Desmos, if we look here, this is going up by 10,000s. Now, think about what I said there. These are very, very large numbers here. Very large numbers. So we don't want to count by ones. So that's what I meant by scale. So I wanted to go back and make sure I spoke to you about that, about the scale. And so over here, I did say scatter plot, but let's make sure that we fill it in. And the appropriate scale used for the value of the truck is 10,000. So that's what we did. We went up by 10,000s on that scale. And for years, well, let's take a look at years. If we look at years, we actually went up by what we had there, by 5. Because we don't want this graph to be so elongated and large that we can't really see what's going on. So, and then years, we went up by 5s. And years, we used 5 years. We used 5 years. So just make sure you word that and explain why it's an appropriate scale. So just make sure you go into that in detail. Again, we use scales to make sure that our graphs aren't so large and so many data points, and because it ends up to be so large sometimes you can't even see it on a computer screen, especially if we went up by ones. Now think about that. If we went up by ones, that's 92,000 points. That's a pretty big graph. So we use scales, went up by 10,000s. So make sure you explain that for that third one. And see, this is always why it's good if you think about the discussion from the last workshop. You always want to go back and check. That was that last step. So here we go. Let's make sure we got everything. And let's go to Desmos and let's graph this here. So we had y equals negative 3,300x plus 2,000. Let's see how to get an appropriate scale here so we can see this better. So over here we have a little wrench. We're going to the graph settings here. And let's change that to 0. And, oh, that's the y, 0. Let's actually make that. And x-axis, we'll start that one at 0. And we'll take that up to about 30 so we can see the graph. All right, so here we go. Now we can see the graph real nicely. And you notice here, I went in here and I said, hey, let's go between, now you can always move the graph between 0 and 30. Basically telling it, hey, I want to see I'm kind of using scales now. So I'm saying, hey, I want to see from 0 to 30. And then from here, I want to be able to see where it crosses, so that's why I put in a value here, just to be able to see it. But then this one here, I can also put in something here as well. And this again is just to simply see the graph. And that will change as I move the graph. But as you see here, it goes up by the 5s, just like we had before, and up by the 10,000s. So let's take a look at this graph a little more nicely here. And if you take a look at crosses I read about here, there's an important point. Okay, that's the intercepts. Intercepts right here. So Desmos is nice because it allows you to click on the intercepts. It shows it pretty nicely. So this is another way to show the graph, another way to just emphasize, what it looks like and also the scales. All right, so if you do need any assistance with this, make sure you please tell me. Again, I'm looking to see this Excel file, and make sure that you put your answers and explanations. Make sure you get a little more detailed, even more detailed than I have here, because I verbally gave more of the descriptions than what I typed, but I typed pretty good here. And make sure you have your scatter plot, your Excel file, save that, put that as part of your initial post, and put the answers to these questions right in the discussion forum as well. So Excel file, put these answers here in that same post. Again, if you need any assistance, please make sure that you know I'm here for you. All right, I hope you have a blessed day.